let's start. Okay, let me share my screen. Right. So again, I'm sorry for Monday that nothing worked. And luckily now I know why. So the problem is that Plutus script, I mean, the Plutus team is introducing a new version of Plutus script. And by default, the Plutus compiler uses this new version, but the Cardano nodes are still on the old version. So in order for everything to work, you have to explicitly tell the compiler to use the old version. So I had to add this line here into the Cabal file, because by default it uses version 1.1.0, but the Cardano nodes on the testnet and the mainnet use 1.0.0. So that was the issue why we got all these problems. So I think today I start by hopefully quickly being able to show that that it now works, and then we can get on with other stuff. So just a brief reminder, so that we are basically using the most simple possible validator, which doesn't do anything. It just allows every spending of UXOs at the validator address. So it completely ignores the datum, the redeemer, and the transaction context, and always returns unit, which means it's okay to spend me. And then we use template Haskell to compile this to Plutus. So and now it will hopefully, because of this compiler switch in the Cabal file, will be compiled to the right version. And we tried two ways for the off-chain side to actually make use of this. One was with the Cardano CLI, and one was with Atlas, the Haskell off-chain library. And so in order to use the Cardano CLI, we need the validator in serialized form. So that helper function here does this. And we also need datum and redeemer. I mean, the values don't matter in this case, but nevertheless, they have to be present. So that's why we have this function. And actually, one other change I made was in these utilities here. Before, I basically did it by hand, writing the validator. So there was this like lots of different byte string types involved to serialize it. And now I changed that to also make use of Atlas. So Atlas has a write validator function already that does this serialization. So I need to take the validator, convert it into a type that Atlas understands with validator from Plutus. That's anyway like a pattern in Atlas. So there are many, many functions that are called something from or to Plutus or API. Because I mentioned last time that one of the difficulties with Plutus is that, I mean, you need all these types like addresses, pub keys, pub key hashes, and so on. And there are different versions floating around, one in Plutus itself, one in the Cardano API that the node uses basically, and then even another one in the so-called Cardano ledger. So sometimes you have like 3 different versions of types. And one thing Atlas does is it introduces its own version to make things complicated, and then conversion functions from and to all the other ones. So I just made that simpler here. And I think this one I left as it was. Okay, so let's try this now. I hope now it works. I mean, I did try it, but now I used Robertino's new setup, so hopefully it still works. Right, so let me start by going into this folder and starting opening a REPL. So going into the on-chain folder, opening a REPL. And I also, not sure, I forgot whether I mentioned it last time. So I've split this into 2 Haskell packages. on-chain and off-chain. You don't strictly speaking need to do that, but I did it because in the on-chain part, in order for this Plutus compiler to work, I need all these weird GHC options, and they make it unpleasant to work with the tooling like the REPL. It's much less helpful than we are used to with regarding to type informations and so on. So I try to basically concentrate the need for these to as little code as possible. And so I moved all the off-chain code into this package where I just used the normal GHC options. So then the tooling here should work as expected. Right, but now I'm in the on-chain part, and let me load this gift module. And let me just do this save val. Let me just check. Just want to make sure that it's this one. I mean, we already have it here. I just want to do this again. So that will serialize validator into this file. And I hope, I mean, nothing changed, so that's looking good. I mean, it changed. Last time we had something else here. That was exactly the problem. So the CBOR hex was different for this different version of Plutus. Okay, so hopefully with this it should work. And now let's look at the script. So first we want to place the gift and then we want to collect it. So I streamlined the script a bit so that it does everything in one step. But what we need is our input. So first of all, we need our address. So let me see. So I have this keys folder with my secret key, but also with the address. So this was the address of the test user we were using. So let me just copy that. Oh yeah, and I forgot I must start my Cardano node. Or actually it's always running. I must just connect to it. Just give me a second. Got. So I have two nodes running on Amazon AWS, a mainnet node, a pre-prod node. And I just need to, and the way communication with Cardano, or one of the ways you can communicate to Cardano node is with a Linux file socket. And normally that's meant to be on the same machine. So that's the recommended thing. If you want to use the socket, you should be, I mean, the node should run on your machine. But the Cardano node, especially for mainnet, takes a lot of hard drive, and it slows, I mean, it takes a lot of resources. So I stopped running one on my own laptop, because then also the problem is, I mean, you always, when you switch off your laptop, then when you switch it back on, then the blockchain has to synchronize again. So it's much better if you can have a node run permanently. So I set an Amazon EC2 instance up that runs the node with enough hard drive. And then if I want to connect to it, then I open a SSH connection and forward the socket so that I have it available on my local machine, and then I can connect to it. I'm not sure whether that's the best setup, but it works for me. As I said last time, of course, you don't even need a node. I mean, you can also use a service like Blockfrost or Maestro. But the Cardano CLI expects a node. So in order to demonstrate the Cardano CLI, we need that. Okay, let me go back here, make it bigger. Maybe go into this folder. Right. And let me first see Cardano CLI query tip. Okay, I need to set this node socket path again. So to tell it where to find the node. Okay, and then I need to say that we are working on the test net. So this, I mean, you can also always specify that with command line, command line parameters to the Cardano CLI. but I find it more convenient to set the environment variable because then I don't always have to do this. And the testnet magic for the pre-prod testnet is 1. Okay, so now hopefully this should at least tell me whether it can connect to the node. So I think we haven't done this query tip before. So that checks basically how much the node is synchronized. So it says 100 here, that's 100%. So that means my node is in sync with the actual blockchain. And now we can do this Cardano CLI query UTXO. And I think it was address. And let me copy that again. So let's check. Okay, and as we see, I played with it a lot. So there are lots of UTXOs here, but the biggest one seems to be this one. So let me use that as input for my transaction. So it's this one, #1. If I go back to my script, make gift. So I just use this #1. That just briefly go through it whether everything is fine. So here I first compute the address and save it in this gift preprod address. That was the file I was checking just now to get the address. Then I build the transaction. So I specify the user is this address. So actually, I think this logically, this line should go there after I've computed it. Then I specify this account as, or this address as the change address where all the change outputs go. This is the one where I actually specify the output going to the smart contract. So this is the smart contract address. That's the amount I've, excuse me. It's the amount I want to give. So 100 ADA. I specify the datum inline using just the unit value and specify where the unsigned transaction should go. Then I sign the unsigned transaction using the private key I created last time in the beginning. Save the result at this in this file, and then I submit it. And finally, I print the transaction ID. So let's hope that works. So I should just be able to execute that now, I hope. Make gift. Already quite encouraging. Yeah, okay. Okay, so I mean, but that worked last time as well, making of the gift. We just couldn't collect it. Okay, so now I can, if I like, open an Explorer, like Cardano again, and set it to preprod. Paste this transaction ID there. Okay, it's not there yet. This always lags behind a couple of seconds. As I said last time, normally the moment I think something went wrong. Okay, there it is. So we see it took 100 ADA and transaction fees from my address, this user address, and send it to this smart contract address. Okay, and we can also now click, for example, on this address. So this is my address, and there we should see so all the transactions, and the last one is this one. So it took 100 ADA and sent it to the smart contract like a minute ago. Okay, and now hopefully, I mean, this part worked last time as well. Now let's see collect gift. Right, and I must specify the UTXO I now want to collect, the gift I want to collect. So if I go back, sorry, if I go back to this transaction, So this was the one. Then UTXOs, I see there were two outputs. So one is the gift, the 100 ADA, and the other one was the change. So 9,194 ADAs were changed going back to the user address. So this is the gift. So so it's the first output, which means it's index 0. So if I take the transaction hash, hash 0 is the UTXO I want to spend, to collect. So that's this one here. Hash 0. And now I explained collateral last time that I have to specify. So it must be a UTXO in my own wallet, in my own at my own address, not at the smart contract address. So I can use the change output. So the change output has the same transaction ID, but it was the second output, so it has hash 1. So that should, and this was the part that failed last time, so hopefully this time it works. So it creates the transaction, signs it, submits it, prints the transaction ID. So let's hope that this works now. Collect gift. I mean, I did try it, but you never know. Yeah, looking good. Right. So now we can check on the, I mean, for example, at the user address, that was this address here. So let's see. So this is still not, I mean, 4 minutes ago was when I made the gift. So I spent 100 ADA. And now let me just, and we see there are 12 transactions involving this address. So let me just refresh until there are 13. Always takes a while. I mean, for several reasons. First of all, as I said, on average on Cardano, there's a block every 20 seconds, but it's just on average. So that's non-deterministic. So it sometimes is much faster, but sometimes takes a minute or so. And secondly, also the Explorer is not immediately catching up. But now there are 13 and I have 100 ADA more. And we see here I received almost 100 ADA. So the difference is again due to transaction fees. So it worked. So now I was able to collect it finally. Yeah, so that worked. And I can also, if I go back to this query, the UTXO, then now I should, it should be different. It's a bit hard to see, of course, but somewhere, I think this one is the one that I now got, the 99.82. So the gift I collected now. Okay, so that works. So that's how you would do it with the Cardano CLI. And now let's briefly also try the Atlas. So let me go to the off-chain part. REPL. And let's go over the code there again as well. Off-chain. So what I did was I import qualified the on-chain part. So this qualified gift validator is the one defined in Plutus, and that in order to use it with the Cardano CLI, we serialized it to disk. If I now want to use Atlas, I don't have to do that in this case. I mean, there's also a way to in Atlas to read a serialized file from disk, so I could do that. But in this case, I don't have to. I can, without explicit serialization, I can immediately make use of this. So there's this validator from Plutus function that I mentioned earlier that converts it into a type that Atlas understands. So this is a validator, Plutus version 2. Then there is, I explained about this monad, which basically has the necessary context. So it's aware of the network you're using, testnet or mainnet and other things, and has the capability to query the blockchain. And one of the functions available in this monad is script address. So we give it a validator and it returns an address. So this is the gift address. And then I have make gift and collect gift, which in this monad, which is like that one, but additionally also can create transactions basically, or transaction skeletons. So this just, I mean, I just use this function to get the address, and then I say, okay, I want to create a transaction that has this output, and an output in Atlas is specified by these fields. So we give the address, we optionally give it a datum. So I just say should be the unit type, specify how the datum should be included. So I say as inline, give a value that was a parameter to this function here. And reference scripts, we will talk about that later, but I don't use them. And collect, very similar, but now I specify that the transaction I'm creating should have specific input. And I mean, in these examples, we don't see that, but actually this skeleton type implements monoid. So if you, I mean, you don't just, I mean, you can't only have, it's not the case that you can only have one condition. You can have several conditions. You can say it must have this output and that output and an input, and you can like combine those with the usual monoid operator. But in this case, we only need one. We only say we want to collect this gift. It will then automatically be sent to the change address. And we just have to give the reference, and we have to specify how we basically legitimize that we can spend that. And in this case, we use this in-witness script. So we provide validator and datum and redeemer, which in our case are just units. And then, I mean, this is a lot of copy paste, but this is now to turn this abstract computation into this abstract monad M into a concrete action that interacts with the node. So I'm using config file, which contains my Maestro or Blockfrost key and specifies logging and so on. Then and so that's the config file is the first argument. The file where to find the private key is the second argument. So I use this Atlas function to read the private key from disk. Then I compute the public key from it. From that, the public key hash. I take the network from the config, and then I can use this Atlas function address from pub key hash, given the network, and the pub key hash gives the address. So that's now the user address, and then I can use this with config provider function, which gives me providers, which are needed to actually run these computations concretely. So there's this run g/tx monad node. It needs the network. It needs these providers. It needs a list of available addresses where to check for possible inputs. So in this case, it's only one address. It needs a change address. Here you can specify something about collateral, but if you say nothing, then the system will automatically pick a suitable one. And then the skeleton. So I'm using this make gift function here. Then I sign it, so I can give it a list of keys with which to sign, and I submit it. And this is exactly the same. So I mean, I should really like abstract this boilerplate away somehow, but I mean, for simplicity, I basically copied everything. The only difference is instead of using make gift, I use collect gift here. So that should hopefully work. I just need these two file paths. So what was I think I have these configs somewhere. Oh yeah, okay. So I have this config core block first. So let's see. So make gift IO. I mean, of course, I could also create an executable, but for simplicity, I want to run it directly from the REPL. So I need this. I never know exactly where I am.
We have a question.
Yes.
Why
yes.
are why are the hashes of public keys used instead of the public keys themselves? Won't hashing them interfere with encryption and decryption?
I mean, it doesn't, and I think it's an extra layer of security. So because it's, I mean, hashing is one-way function. So if you have the public key, you can get the hash, but not the other way around. It's basically, I mean, it means if you only know the hash, you can't get the public key. So, I mean, it makes it even more difficult to somehow crack the private key. And no, I mean, so you can check whether, I mean, the signature, you can check it if you only know the hash. It's actually a good question why you can, but you can. I mean, you don't need the public key to check the signature. So you can, I mean, the transaction needs to be signed, or if you get the signature, then it's possible to check just knowing the hash that it's the correct signature. So you don't need the public key in order to verify the signature. And it just makes it a little bit more secure still. But I think in principle, I mean, it's not really, I mean, you could also work with public keys directly, but they are also bigger. So it makes addresses shorter if you use the hash instead. Hope that
Doesn't
answers
also,
it.
doesn't also help with privacy because you can virtually use any, yeah, you can have multiple hashes, so you don't have to expose your public key.
Yes, I mean, exactly. So you don't have to expose your public key. I mean, so that's an extra layer. But I think there's not, I mean, even if you expose your public key, I think that should be fine. But yes, so you make it even more difficult to crack your private key because people don't even have your public key.
You know, also you can do like every transaction with a different hash.
Yeah, but that is a different story. I mean, then you also need a different public key.
Right. Okay.
Um, so I mean, there's only one hash per public key. That's true, and I mean that's actually what wallets do. So if you use a wallet, not any, I mean, like Nami not, but like Eternal, for example, or Daedalus or Lace, they are so-called HD wallets. So they I mean, that's a bit more complicated. So you create like a master public key. It's a so-called extended public key or private key in the beginning, public-private key pair. And then from this master key, for every transaction in principle, you can derive a new public key and secret key. So you never have to reuse the same one again. And that's so called HD wallet for hierarchical deterministic wallet. And that's incidentally the reason why this function here takes a list of addresses and not just one address. So if you use that in the context of a wallet, then you don't just have one address, you have like a lot of addresses, potentially infinitely many. So you can give it a list of addresses because the funds in the wallet don't all sit at the same address. They basically use different addresses. Yes, but that has nothing to do with hashing. I mean, I mean, you have different public keys then each time.
Cool.
Okay, so now I don't know, I can use Block Frost Maestro. Doesn't matter. Okay, and then next, the other one that I need is this user ASCII file. I mean, this we did, oh yeah, the value. So I can say value singleton. I always forget which way around, whether the unit comes first or the amount. So let's say 100 again, or whatever. This time, let's say 200. 1, 2, 3, 1, 2, 3, loveless. Okay, it's the wrong way around. So the loveless comes first. Okay, so this is logging. I mean, part of the configuration is that you can figure a logger, and I just use standard error logging. And this is just some logging that's happening. It basically shows me the skeleton. So, I mean, this output I specified. Okay, so this seems to have worked, hopefully. But I mean, that's how far we got last time as well. Let's just refresh here the wallet again. That's 13. We must wait until it's 14. Okay. So if we look at the last transaction, so now it's 200 ADA and the smart contract received 200. And now finally, I mean, this we also got last time, but now let me, so what, for collect, I must also specify the two files and then the TX outref. So I think for that I have to set overloaded strings because I want to specify the TX outref as a string. So now instead of make gift, collect gift, these two files are the same, but now instead of the amount, I must specify which gift to collect. So this was this last transaction. So if I copy the hash, I mean, I could also have taken it here from the output, this one. I mean, this. And now, I mean, the gift itself is always the first output, so hash 0. Now, hopefully, I mean, this is the part that last time also didn't work due to this version conflict. Oh, let's hope it works this time. Yeah, it seems to. Right. And now we can again try to refresh until we get 15 transactions. And then hopefully we get our 200 data back. Okay, 15. Yes, so we received 199.827 something. So yeah, so that also worked. I mean, it's not a very impressive smart contract because it isn't really smart. It always says, okay, take me, but nevertheless. Okay, are there any, so that's how it was supposed to work on Monday. So are there any questions at this point?
Not so far.
Okay, so that was first Cardano. No, I mean, Marlow was also smart contracts, of course. But this was your first like pure Plutus contract in action. Right. So now, I mean, of course, let's go back to on-chain. Or actually, let's go now to this week on-chain. Okay. Let me close this. Let me open this. Right. So this gift validator was, I mean, if you look at it again, so it accepted everything and always returned unit. So now, I mean, this is like arguably the simplest smart contract you can write on Cardano. Now, the second simple smart contract you can write is the one, I mean, this is the one that always succeeds. And the second simplest would be the one that always fails. And I explained last time, I mean, this is a bit weird for Haskell to have a return type of unit, because the only way you, I mean, the only result you can possibly get is unit. But on Haskell, every type always has this exceptional value. Some people call bottom, I mean, which corresponds to an error, an exception, or an infinite loop or something. So that is the other option, how we see the failure, that it's not okay to spend me. And sorry, I can close. So the way that is done, or one way to do it, let me just import Plutus TX prelude. So as we I mean, the simplest way actually, right, or okay. I mean, we are used to the prelude. The prelude always implicitly gets imported in Haskell code if we don't explicitly forbid that. And normally, I'm not sure, I think we never have explicitly forbidden it yet. The problem with Plutus is Plutus uses its own prelude. So which conflicts with the Haskell prelude. And that's in module Plutus to X prelude. So you don't want the normal Haskell prelude floating around. And there's this extension to GHG, which is called no implicit prelude. So if you use this extension, then Plutus is not automatically, sorry, the prelude is not automatically imported. So I do get this error, but I think that's because I didn't go to the burn. So now let me go to this again. Right. Okay. So there's this other prelude. And I mean, one of my annoyances with Plutus is that some things in the Plutus prelude have the same name as something in the usual Haskell prelude, a different signature. So if we, maybe before I should have done that, sorry, let me just close that again. If I go back, so now the Haskell prelude is, the normal Haskell prelude is still active. So if I ask for the type of error, then that's what we are used to. That it takes an error message and then returns any type. So, I mean, I can say error, whatever error, and or this is an error, and then when Haskell tries to evaluate that, then it would basically display this error string when I try to evaluate it in the REPL or in executable. But now, if I go to this burn module, got this. So there's also something called error. Ugh. I don't know why. I mean, shouldn't it to be excluded? Anyway,
Maybe other module imported it.
yeah. But I can qualify it, I suppose. Right. So error in the Plutus prelude has a different type. It doesn't take this error message as a argument, which I find is confusing. That the Plutus team created functions with the same name as in the normal prelude, but with a different signature. But it's what it is. But there are also like variations on this. So there's, for example, something called trace error in the Plutus prelude. And that does take a string. So Plutus uses something called built-in string, which also implements isString. So if you have the overloaded strings extension, then you can use literals for that. So that basically does what error does in the normal Haskell prelude. So in this example here, I use this trace error, so I can give an error message. And right, so this is now the smart contract. If you send something to this address, you can never retrieve it again. That's why I call it burn, because I mean, in crypto, normally if you do that, if you send, I mean, if you remove funds, then you say you burn them. It's not really burned. I mean, it will sit there forever at that UTXO. It's just lost to humanity or to also anybody else, because it can never be retrieved again. So whenever somebody tries to retrieve something from this burn address, it will just fail. So the validator just fails. So and this is just the same. So this is always this boilerplate to compile it with template Haskell and using the compile function. And this is to save it. So let me do this. No, I don't do this because I mean, I would only need to save it if I want to use the Cardano CLI, but I think I prefer to use Atlas. I mean, that's much more convenient. Then we don't always have to fiddle by hand with the scripts and so on. Right. So let's try this. I mean, obviously you can't retrieve it because that's exactly the point of burning. But I nevertheless want to demonstrate what happens. So I also have this off chain. And at the moment, I just copy pasted everything from the gift. So let me just so do this import qualified, but now burn. And remove the comments. And let's go to the off-chain part. Should give an error now because I just copied. Doesn't. It's a bit. Just check. Probably I imported the wrong one, the old one still. No, didn't. Bitconf, or I didn't save. Sorry, all good. I didn't save this. So it should fail because I'm still referring to gift, but gift is in a different package. Right. So in principle, everything's the same. I mean, I can even still call it. I mean, probably I should call this now burn validator. Can it automatically rename it? For some reason, struggling. I don't know why, but I can do it by hand, of course. For some reason, it didn't work. The automatical renaming. So this is now burn validator. Burn address. I probably should automatically rename everything. So what's that? Just give me a second. So gift address. Now burn address. Let's see. We just reload. Okay, that explains this. Okay, I'm afraid now I have to go out and reload it again so that the dependency is updated.
Out of where?
I'm sorry, out of the REPL.
Okay.
Because otherwise, this is in the on-chain package, and I think if you change the dependency, basically the REPL doesn't automatically update that. You have to leave it and start it again,
Yeah,
if I'm not mistaken.
yeah, you're right. I thought you meant the container.
No, 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 luckily not. Sorry. Okay. So this is now burn validator. Okay. Just a second. I mean, this is just for debugging, this namespace, debugging namespace. Right. Make gift, collect gift, burn validator. Okay, let's see. Okay, this compiles now. Okay, now I can try to make the gift. I mean, that should work, of course. So it's again the same thing. I can use config whatever block first. Now again, user S key. Now the amount. So seeing as it's gone forever, let me. I mean, it doesn't matter. It's. I mean, it's just 10 net money, but nevertheless. Singleton. What was it first? The unit. So loveless. Whatever. Let's say 3 loveless. So like this. So that should work. And we can check again in the Explorer until it's 16 transactions. I just want to show you what happens if basically a smart contract fails. Or it says that, I mean, if I should say if that validation fails. So this should work because as I explained last time, I mean, no validation happens at this point in this transaction because I'm sending to a smart contract address. The validator, the Plutus script is only executed if you try to spend from it, not when you send something there. So you can always send whatever you like anywhere. That's also something to keep in mind when you design smart contracts. You can never assume that you are the only one sending something to a specific address. Can't prevent people from sending stuff there. Okay, now it's 16, so the 3-ADA. And it's, again, of course, the first output. So now I can try to collect gift. And that should hopefully fail now. So I must again set X overloaded over strings. So collect. So it's this transaction ID #0. And I'm not completely sure what we will see, but it should definitely fail. Okay, so it does fail. That's good. But we do. I was wondering whether we do see the error message, but I think we don't see it. But I mean, there are ways I think to see error messages, but this is not the one. I mean, I specified this this it burns string, but I think we don't see it here, right? That is, I think, done for performance. That these strings are, I mean, they are basically just for debugging. So I mean, but we do see here. I mean, this is so we get a script execution error. And it says it's the script index, script witness at index 0. So that is exactly, I mean, we only have one input and that is at index 0. And it says script error evaluation failed. So that means the script actually executed and then said validation is not okay. And an error occurred, user error, machine terminated because of an error, blah, blah, blah. But it doesn't give the error message. I'm pretty sure there is a way to configure Plutus in a way that it does give error messages, but unfortunately I don't know how. But never, because I know if you use one of the alternatives to Plutus TX, written by a different company, by MLabs, this so-called Plutarch, which is also Haskell, but a different, I mean, a more low-level way of writing smart contracts, then there is actually a way to get these error messages. Assume you somehow can also get them here, but I don't.
May-
Maybe I don't know. Yeah, what do you
Maybe
know
they
if it?
are. maybe they're being filtrated by Atlas, because I can see them using other tools. Lucid, for example,
Ah,
you can actually see them using Plutus and Lucid.
I don't think it's interesting. I don't think that Atlas has anything to do with it, but I don't know. But we will talk about Lucid at some point, so
Yeah.
then maybe we can revisit it. But I mean, the important part is that it fails. And we see it doesn't fail for some other, I mean, not like last time because some word conflict or whatever. I mean, we see that the script execution error. So yeah, maybe it's Atlas, I don't know. I mean, we could try it in the CLI, of course, whether, I'm not sure what happens in the Cardano CLI, whether you see it there.
Mm,
But in any case, we see that it fails.
yeah. And we get enough
Okay.
information to know why as well. So yeah, there is this performance enhancement that everything gets, all the strings get removed.
Yes.
Maybe that's already like by default turned on in Atlas or something.
Yeah, might be. I'm not sure exactly. But I mean, I'm not using Atlas to generate the script. I mean, I mean, the compilation part is basically pure Plutus. So it's a bit, I'm not exactly sure. So it's not stripped out of the script itself. The script, I think, still contains this string. So for some reason, it's just not displayed. I mean, but I think, for example, if you, I mean, next week we will talk about testing, and I'm pretty sure in Pluto Simple Model you see it, the
Yeah.
error message. Right. Anyway, so this is what happens if it fails. So then you, and as I also said, I mean, I think one of the great things about Cardano is that in this case you don't have to pay. I mean, it just fails. So if I go to the Explorer, then I mean nothing happened here. I mean, it's still 16 and will stay 16. So I mean, it fails, but I don't have to pay anything for that. So no gas fees. On Ethereum, in this, if you did something like that in Ethereum, you would still need to pay gas fees, and the transaction would fail. And here, I mean, before you even submit it, um, you already get an error that I mean, the script just doesn't validate. So there's nothing. I mean, you don't lose any money. You just can't. You can't even submit the transaction. You actually can submit the transaction if you insist, but you already know it will fail. And that's why you need collateral. So if you do, I mean, that's then you would lose the collateral. If I now overrode the safety features of the Cardano node and force it to submit, then in this case, I would lose my collateral, or part of my collateral, because it's a failing transaction. But that never happens if you don't override the safety features of the node. Right. And so that's that. Are there questions at this point?
No.
Okay, so maybe we can do one more example before we have a break. So, I mean, until now, I've completely ignored the three arguments to the validator, right? And I mean, so basically, I now showed you the two validators that do that. So, I mean, if you don't look at the arguments, then you can only do two things. Either you always succeed or you always fail. And I demonstrate both. So that was the gift and the burn. So now let's look at an example where we actually look at the redeemer. And the idea is the transaction should only succeed if the redeemer is 42. I mean, we looked at this built-in data type earlier, and I said it's like similar to JSON. And in particular, it has like byte strings and booleans and integers as, I'm not sure about booleans, but byte strings and integers as primitives. So the idea is if you give it the built-in data that corresponds to 40, the integer 42, it should succeed, and otherwise it should fail. And I mean, it's just basically normal Haskell. So I mean, it's just a Haskell function. So you can do exactly the same that you would do in normal Haskell. So built-ins has this built-ins is Plutus TX. So let me just go out again because I was in on-chain, and let me go back. Sorry, I was in off-chain. Let me go back to on-chain. REPL. Node 42. Let me import Plutus TX built-ins. Plutus TX. Okay, and if we ask for this make I function, so it takes an integer and results in built-in data. So I can do make I 42, and I mean the constructor is called I, so gives me that. So I just check whether my redeemer is that, and in that case, I return unit, and if not, then I do an error. And the rest is again the same. Let me, I mean, okay, fine. It's just called validator. So let me keep, yeah, let me keep that. And let's try it out. So let's leave again. Go to off-chain, REPL. Log off-chain. Okay, off-chain. Sorry, my Zoom thing is in the way. Off-chain. Let me just copy this. Are these two? Sorry. It's 4, of course. Okay, let's call it make 42. Okay, so this is all the same. Okay, now I have 42 validator, 42 validator, 42. It's called validator there. Okay, make gift, collect gift, blah, blah, blah. Make 42. Collect 42. Make 42 IO. Collect 42 IO. Right. Now for make, this is basically identical. So what was it called? 42 address. Right. So there I don't have to do anything. Now collect 52. Let me specify here which redeemer to use. So let's say built-in data. And then here, and instead of always using unit, just 1 second, redeem. What's this redeemer from Plutus? Try, I think that's what we want. Right. So, I mean, until now, we use this redeemer from Plutus data, which takes a Haskell value. If I want to specifically use some specific built-in data, there's this redeemer from Plutus Prime that takes built-in data and gives me a redeemer. So I can use that redeemer from Plutus Prime R.
We have a question.
Yes.
Are there any memory or space concerns in using integer, which is unbound in a Plutus validator?
I mean, potentially, of course, if it's a very large integer, then obviously it will make the validator bigger but I mean, as long as you do something like 42, I mean, it's relatively compact. And that actually is one of the like improvements of Plutus over Ethereum or Solidity. I mean, one source of bugs or exploits in Ethereum are these overflow problems. Because Ethereum, I mean, Solidity, yeah, the EVM, the Ethereum virtual machine uses bound number types. And there have been exploits in the past where people use that. So if you're not careful in Ethereum, you always have to check whether you get a numeric overflow. And people have exploited that to steal money on Ethereum. And I think that's the reason why Cardano and Plutus, they decided to use integer. So you don't have to worry about overflows. But of course, you're right. I mean, if you use extremely big numbers, then it makes your contract more expensive and bigger. But I think it was a safety thing that was on purpose so that you don't run into these overflow problems. Right, this was collect. Just okay, built-in data is not in scope. I think that's because I'm not importing Plutus TX. So let me do that. Is it? I always forget. Oh, it's with a minus. So let me just do this. Now I also have to reload when you change your Cobol file. You have to reload the REPL, not the container. I mean, I will still get the error, of course, but now it should be. Let me just a second. Okay, that's in Plutus TX. Fine. So let's go here. Okay. 25. Okay. Okay. So make 42, collect 42. Yeah, that I already changed. And now the IO versions. Of course, here it must be make 42. Right, and collect 42. Now, of course, also needs to take this additional argument, the redeemer. And must call it at the appropriate point. Everything else should be fine, hopefully. Right. So now we can try this out. So let's do make 42 IO. So again, project config core. Let's take Maestro for a change. And keys. I mean, of course, I could also hard code that somehow, but anyway, user S key and how much. So value singleton, loveless, whatever, 123 ADA. I can also 4, 5, 6, 7, 8, 9 do something like this, just for fun. So we place this. Okay, can check. It's always a bit tedious, of course, that one has to wait, but on the other hand, I also think it's cool that all of this is basically happening publicly on the blockchain. And that's, I mean, the first time I taught Plutus 2.5 years ago or so, it was before it was available on the blockchain. So then it was all quite theoretical. And there was something called emulator traces, where you could basically, and a playground, where you could run these things on a simulated blockchain. But I think it's much more fun if you can run it on the actual blockchain. But then, of course, you also have to live with the timing on the actual blockchain. Okay, there it is. So this was our, so there's now a different address because it's a different contract. I mean, we could have seen that with the burn as well. So, I mean, this here, this KLA thing was the gift address. The burn address is different because the address of a smart contract is, as I explained last time, it's basically, it's the hash of the script. And if the script is different, the hash is different normally. Sorry. Right, so each different script gives us a different address. This was the burn address, and now we have this 42 address, which is this one. And the 123.4567898 ADA are there now. And now I can try to collect it. So I copy this transaction hash. And I think I must import Plutus TX. So now let's see if I collect 42. So I must I forgot, I think, overloaded strings, so I will get an error because of that. So now if I do whatever, let me just press enter. So of course, it doesn't work. Overloaded strings, and I also, oh yeah, I must import this Plutus TX built-ins. Now I have, I mean, I have this make integer, I have make list, make map, make constructor, make bull. So I could, for example, get a byte string built-in data. Right, so now, so that was this, and now let's first try with the wrong redeemer. So for example, make string Kenya. So this should now fail because the validator should only succeed if I give the integer 42. And we again see it has this script execution error. Although, hang on, that's a different error. It says missing script. So probably I provide the wrong script somewhere. Well, first of all, I mean, it doesn't matter. This is just for outputs, but nevertheless, I should maybe call it 42 here as well. That doesn't matter. That has nothing to do with how the program actually behaves. But I think somewhere yeah, here. I mean, the error is different. It says missing script. So as I explained last time, when you try to spend from a smart contract, the spender has to actually give the actual script. because the address only is the hash of the script. For the node, in order to be able to run the script, it must somehow get the script, and the spending transaction is responsible for providing it. And so that's what I do here when I specify the input, but I forgot to change this to 42 validator. And therefore now I got the error that the script is missing. So I attached the wrong script, which doesn't hash to the right address. So the node didn't know what to actually execute. So let me try this again. It should still fail because the redeemer is not the expected one, but it should fail with a different.
You need to reload thing, Lars.
I'm sorry? Didn't I reload?
Yeah, I think.
Okay. Right. Okay, so now we get user error. I mean, we unfortunately still don't see the error message, but now it's basically so it's different now. So now it's the right script and it executes it, but then execution fails because it checks for the redeemer integer 42, but it got redeemer string Kenya. So now if I instead run it with 42, I mean, if I run it with 41, it should still fail. All right. But if I run it with 42, it hopefully succeeds. Yes. Okay, now after a bit of patience, when we get 18 transactions, we should have our 123.45678.9 ADA back. Okay, there we go. So we got it back. Of course, we didn't get everything back again due to transaction fees. Right, so that was the first example of a validator that actually does something. I mean, looks at its arguments, in this case, the redeem. Of course, it's still a silly example because I mean, I can't really think of a real world use case for this one. But nevertheless. Okay, so I suggest we have a short break, maybe until, I don't know, 35. And then we'll talk next about typed Plutus, because right now it feels like doing JavaScript or something because of this built-in am I not? I mean, because of this built-in data, everything is built-in data. I mean, that's horrible. That really feels like JavaScript, where you have no type safety whatsoever. So next we will see how to improve that instead of just having built-in data there, you can have like proper Haskell types, different Haskell types there. But we can do that after the break.
Okay.
So, okay, let's have a break until, 35.
Sure.
Okay.
Okay, thank you.
Yes.
Okay, so as I said, this is annoying. It feels like writing JavaScript, like working in untyped language, that everything is built in data. It's what some people call a blob type. So it's a type, but everything has the same type. And we don't have to do that. So what we would like is to write validator like this with types. So in our case, I mean, as an example, we don't make use of datum, so that morally should be unit. We make use of the redeemer, but we are only, I mean, let's say we only worry about integers. So we would like the redeemer to be of type integer. And the script context, there is a type that we will look at in more detail later today that represents context. So that type is called script context. So we would like to write our validator like strongly typed in this form. And finally, this unit is annoying, so we would much prefer to have the Boolean there instead of unit. And then we return true if validation succeeds and false if it doesn't. And that's possible. So what this here does, I mean, this trace is false. I mean, for the time being, we can ignore this. So, I mean, we would like to write it like this. So looks at the redeemer. The redeemer is now an integer, and we check whether that integer is 42. There is this helper function trace if false. So what that does is it takes a Boolean, evaluates the Boolean. If the Boolean is true, this expression just returns true. And if the Boolean is false, the expression returns false, but this here is traced. And as we discussed before, at the moment, we don't see these trace messages, but there are ways to make them visible. So yeah, that's like help for debugging. Right, and in order, but I mean, nevertheless, we still need something of this type in the end. And I wrote a helper function for that. That's also in these utilities that are called wrap validator. So let's look at the utilities. So it's here. So it takes a function from some datum type A, redeemer type B, script context to bool, and converts it into a function of the type Plutus. The compiler is expecting built-in data, built-in data, built-in data. And it does that by making use of a type class we haven't talked about yet. So it's called unsafe from data. Maybe we can look at, can try to Google that, not sure. Unsafe from data, Plutus. Right, so there is a class defined in the Plutus libraries from data, and that provides this, or there's actually a class unsafe from data. And which one did I use exactly? Unsafe from built-in data. So if you, I think this is old now. I'm not completely sure because, no, sorry. So unsafe from data, and that has a function that can convert built-in data to A if you're an instance of that class. So what it will do is it will try to, I mean, it's like deserialization, right? I mean, you can think of built-in data like JSON. So this is like the from JSON class in the ASON library. So it tries to deserialize this built-in data into the Haskell type A. And if it succeeds, you get an A. And if it fails, you get an error. So the script will just error because the conversion fails. And using that, we can write this function. So I mean, we in order to, so we want a function like, so we want a function like this. So we have a type function f, and we want to convert it into a function that takes 3 built-in datas. So these 3 built-in datas are, I call A, B, and context. And then I use this unsafe from built-in data on A, on B, and on context to convert it into, no, sorry, I mean, they are built-in data now. I mean, because we want to create a function like this. So A, B, context have type built-in data. So I use this unsafe from built-in data to convert it into the Haskell types A, B, and script context, apply my typed function to it. So then I get a Boolean, true or false. And finally, I use this check function that's also defined in the Plutus libraries in the prelude. And it has type bool to unit. And what it does is, if the Boolean is true, it will just return unit. And if the Boolean is false, it will use error to error out. So that's exactly what we want. So it basically converts true to unit and false to an error. And using this, I mean, I defined this helper function, but of course you could also do that like by hand directly. We can then write our function like this. And then when we compile, sorry, wrong file. We were in the typed one. We apply this wrap validator to convert a type function into function of this type, and then compile it. Okay, and that's how normally we would do it when we work with I mean, when we use this method to get to Plutus, this Plutus TX, where we write our functions in Haskell. One should mention, though, that that comes with a slight, or maybe depending on context, not so slight performance impact, because I mean, the validator now has to do these conversions. So it has to do this deserialization, which of course takes execution steps and makes the transaction more expensive. So there are also third-party tools that try to solve that problem, that you don't deserialize everything, but only what you have to. But that's like an advanced topic. Nevertheless, so that's how we would normally do it. And this works because unit, integer, and script context are instances of this unsafe from data. There's also a class 2 data, which does the opposite, which corresponds to JSON, to the ASON class 2 JSON, which allows you to convert an A into built-in data. Right. So that is that, and I think I don't need to demonstrate that. I mean, that always takes a lot of time on the blockchain. I think we wouldn't really gain anything from that. The point is just that if I tried this and then use something that's not an integer as the redeemer, it would also fail, but then it would already fail in this unsafe from built-in data step when it tries to deserialize it. So the contract can only succeed if I provide the right types. And then, of course, the validation logic also. So in this example, it needs to be 42. Are there any questions to that?
Not so far.
Good. So now, of course, the question is, what do you do if you don't use a type that has an unsafe from data instance? And the Plutus team has covered you there as well. So I think we don't have to waste too much time on this. So if I instead of integer, use some custom type that I now called my silly redeemer, which is just a new, in this example, just a new type wrapper around integer. Then, of course, my silly redeemer type doesn't have an unsafe from data instance, because the Plutus team obviously didn't know about this type. And then there is a template Haskell function called unstable make is data, which uses template Haskell to write this instance. So I can just get, so make is data is a combination of two data and from data. So it will provide instances to serialize this type and from built-in data. And then you can just use it as you would expect. Good question, of course, is what is unstable about it? Let me just see whether that's available here. Yeah, it is. So this is this function. So the problem, I mean, why it's called unstable is that the serialization somehow depends on, I mean, if you later change the type, if you add field, I mean, if you have a record type, for example, you add fields or you reorder constructors or whatever, then the serialization might be different. And maybe, I mean, smart contracts potentially can run for a very long time, be on the blockchain for a very long time. So this is a bit fragile. And therefore, there's also this make is data indexed version, where you explicitly say for each constructor which constructor index in the built-in data type it should use. So it's recommended that for production code you use that and not the unstable version. But for like trying stuff out, the unstable is fine. Okay, are there questions to that? If not, then I think,
Good.
yeah, so now there are two directions we can go to now, parameterized contracts and looking at an example using the script context. I'm not really sure what I should do first. maybe.
The script context is simpler, maybe.
Mhm.
Mm.
Right.
Yeah, Jason, have a question, Lars?
Yes.
Does compile code have types?
Mm, I think that's a good question. I mean, there is something called untyped Plutus core. So I think at the lowest level, it doesn't have types.
Yeah. Yes, I think it's asking like the actual compile code type, but for the way it's written.
I mean, the compiled code has this type parameter, so there could be anything here. But I mean, like a validator always needs this type, so it must always be built-in data, built-in data, built-in data unit. I mean, you could have compiled code with arbitrary type here, but it's only useful as a validator if it has this one. So at the lowest level, it just uses this built-in data. Not sure whether that answers that.
Not sure.
Mm.
I'm waiting for the answer.
Yeah.
Sorry.
Jason?
Oh, can you hear me?
Yes.
Yes.
Yes, yes.
Oh, okay. I was just wondering, does type information transfer to like the validator itself? Like,
I mean, no, I mean, this rep validator, I mean, before I even send it to the compiler, the types are already removed. So, I mean, this still happens on the Haskell side. So the compiler only sees this version from built-in data, built-in data, built-in data. So that type information is not on the script level. It's just on the Haskell level.
oh, okay,
So the
okay,
answer is no. Yeah,
okay. Thanks. Got it.
welcome. Right. So the script context, I'm never sure which is where, but no, that's not there. I think that's in this letter API thing. So script context, Plutus. Right. So we are using Plutus v2. There's also Plutus v1, but let's look at the Plutus v2. I think this is still not the right version probably, but I think that it's fine. I think the type itself is the same, so we can look at that. So this context, and when I explained the extended UTXO model, I said it's basically the transaction that's being validated, which of course was a bit vague. So let's look at this. So it's this script context type, and that's a record with two fields, info and purpose. Let's look at purpose first. Everything we have talked about Plutus, we discussed in Plutus right now, uses this purpose, spending. So that's a smart contract that is run by the node when you validate a transaction. When you validate an input to a transaction, that comes from a smart contract address. So then these validators are executed. And in that case, the purpose of the context will be spending. We'll use the spending constructor. And this TX outref will be the TX outref of the input you are just trying to spend, to consume. And as you can see here, there are other purposes. So smart contracts on Cardano, I mean, the most common case is this one that we have been talking about now, spending an input. But there are these three others. And the second most common is minting. So I'm not completely sure whether we have time to that today. I hope so. Otherwise, we do that on Monday. So I mentioned native tokens before. So everybody can mint their own currency on Cardano. And that also involves smart contracts. There's each custom currency comes with a so-called minting policy. And that's again a Pluto smart contract. And I mean, I I mean, I'll explain later when we talk about it in more detail, but the idea is when you try to mint this currency, then the corresponding Plutus script is executed to check whether minting by this transaction is okay. And also when you try to burn these tokens, then the script is executed. And then there are two more purposes. I don't even really know. I've never tried the certifying one. I mean, there are various certificates on Cardano, like when you register a stake pool or register or delegate to a stake pool or deregister a stake pool. So you can do involve smart contracts there as well. And this is interesting, but it's also not commonly used yet, even though it opens a lot of possibilities. I mean, on Cardano, we have this concept of staking. You can stake your ADA. And for that, I mean, Cardano addresses have two parts, a payment part and a staking part. The payment part is responsible for deciding who can spend an input. So we have talked about pub key addresses, by which I mean that the payment part of the address is given by a pub key hash. And we have now seen examples where you can, instead of a pub key hash, have Plutus scripts or the hash of a Plutus script. But that's also for the payment part. So it's about spending, when you can spend. There's the second part of an address, the staking part, which governs what happens with the ADA contained in a UTXO sitting at that address with regards to staking, to which stake pool it's delegated, for example. And in like most cases on Cardano, this is given by a pub key hash as well, your so-called staking key, but that can also be a Plutus script. And I mean, one of the things you can do with staking, so you gain staking rewards every 5 days, and then you can collect those staking rewards in a transaction. And if your staking key, I mean, staking part of the address is given by a script, then this script will be executed if you try to collect rewards. So we are not sure yet. It depends a bit on how fast we proceed next week, but maybe towards the end of this Plutus lectures, we will talk about, I mean, have an example of that. So that allows you to do things that you, I mean, for example, you could have something like multi-sig for staking that two people have to sign if you want to withdraw staking rewards, or you could have something that each time you withdraw, 50% of the rewards go to some charity or something like that. So there are also lots of possibilities. But to my knowledge, very few people make use of that at the moment. So the overwhelming majority of use cases for Plutus is these custom currencies and spending. So that's the script purpose, which is contained in the context. And TX info is the information about the transaction itself. So I'm not sure whether we will see examples of everything, but just to give you an overview. So that's a large record type. So you have access to the list of inputs to the transaction. And if we drill into this type, then in particular, we see basically the reference, the TX outref of the input. And we can drill in further and we get the address, the value, and the datum hash. And so that's the inputs. Then we have the outputs. Again, for each output, we have the address, the value, and the datum hash. Actually, I think this is an old version of that's. I'm not completely sure. No, that's script version 1. Actually, I want version 2. Sorry. So it's a bit different there. Right. Just see. Yes. So it's not just the hash. Sorry, that's Plutus version 1. So version 2. I mean, what I said about purpose is still the same, I think. I hope. Did I tell you something wrong? I must be careful. No, I think that's still the same, right? Yeah, nothing I said there was wrong. Difference is this TX info type is a little bit different. So this, in particular, this TX out. So instead of just getting the datum hash, now we get something called output datum. And this output datum reflects these different possibilities. So there could be no output datum. We could just have the hash, or in the case of inline datum, we actually have the datum itself. The datum is just this piece of data. So that was one of the changes of version 2. Then these reference inputs. It's now possible to have inputs to a transaction that are not proper inputs, but so-called reference inputs, which means the transaction doesn't spend them. So they stay as they are, but the transaction can look at them. And that's one of the challenges with the UTXO model is that, I mean, UTXO can only be spent obviously by one transaction. If it's spent, it's spent. So if two transactions try to spend the same UTXO, only one of them, or at most one of them, will succeed. These reference inputs, however, can be used as, I mean, UTXO can be used as a reference input to arbitrarily many transactions because it doesn't get spent. And also, if it happens to sit at a smart contract address, it won't be validated, so the script won't be executed. So that's useful sometimes. Okay, then we have the outputs of the transaction. We have the fee. Mint is for native tokens. If you try to create new tokens or burn existing ones, then that's reflected in this value. Then these certificates, as I said before, that's like for registering a stake pool or deregistering and stuff like that. This is withdrawals. So if you try to withdraw in the transaction, withdraw rewards, then it's a map for which staking credential you withdraw how much, ADA or Loveless. We will talk about time soon, maybe now even, but let's go over that for a second. So this is something about when the transaction is valid. This is the list of people that have, or private keys that have signed the transaction given by their public key hash. So you can check whether a transaction has been signed by whoever. You can see all the redeemers. So not only your own redeemer, I mean, the validator always gets its own redeemer, of course, if it's a validator, but you can also see like the other redeemers if more smart contracts are revolved in this transaction. This here is, I explained now several times already, that there are 3 ways to attach datum to an output. One is, I mean, the one I recommend is to inline it. And then there are these 2 old ones. One is to just attach the datum hash. And the third one is to attach the datum hash, but include datum itself in the transaction. And that's where this comes in. So if you do that, then the body of the transaction is TF info data, is basically a lookup table where for a given datum hash, you can look up the corresponding datum. And finally, the transaction ID. So that's the information you have available in this context. And that's when you run a validator, for example, then you always have access to this information. Are there any questions to this?
No.
Okay. Right, so now I'm thinking, should I talk about time first, or should I first do an example that involves the context but not time? I mean, I think it fun example, one of my favorite examples is like an atomic swap. I think that's quite a good example.
Yep.
Do you think I should do that? And that's actually it's actually a useful example. It's like a bit more complicated, but actually useful. I mean, you could do that right now to build your own DEX in principle, decentralized exchange. Right. So the idea is, I mean, I have some value in my wallet, and I want to sell it for a certain price. But I mean, but we are on the blockchain, and I don't know people, so how do I do that? I mean, obviously I could, I mean, I can agree. I mean, for example, let me just show off. Maybe now I can actually use this. Just give me a second. For the Marlow lecture. Oh no, maybe that's the wrong one. No, sorry, that's the wrong. Sorry, just saying. Actually, for the Marlow lecture, we didn't have time for that then in the end, but I wanted to. I mean, I minted this token, this NFT. I think I did. I must just find it again. Yeah, this one. So I minted this this NFT, I think. Just see. Right.
Lars, we have a question.
Yes.
Jim asks, does TX-info signatures means keys that send ADA to the validator?
No, it means signatures that are included in the transaction. When we saw, I mean, when we used the Cardano CLI after we created the transaction, we had to sign it first, and then we could submit it. So I mean, most transactions, I mean, not especially, I mean, transactions can be signed. I mean, the normal case is if I send money to Karina now, and I spend money from one of my pub key hash addresses, then in order to show, I mean, to convince the node that it's okay to spend UTXO, the owner of the address must sign the transaction. So that's like in 99% of transactions on Cardano, it's simple as that. Doesn't involve smart contracts. You just send money from A to B, and the owner of A has to, I mean, A has to sign. So that, I mean, otherwise people could take my money. So if the UTXO belonging to my pub key hash address is spent, then I have to sign. And so you can sign transactions. You can attach your digital signatures to a transaction. I mean, most cases it's only one signature, one person, but it can be a list. And the contract has access to that list. So it can inspect who signed the transaction. Does that answer the question?
I hope. Yeah, it's okay. Yes, thanks.
Okay, right. Yeah, anyway, so let's say I don't want to restore. Right, I mean, it doesn't matter, but I mean, anyway, I mean, I have this thing that my Nairobi coin, and I even attached some metadata to it, like a picture of the class. And I mean, this is now an NFT. NFT means it's a custom token, native token on Cardano that only exists once. So there's only one coin of it. And I have that now in my wallet. And let's say I want to sell it to Karina. But of course, I don't trust Karina. So I mean, I mean, we agree she wants to pay 100 ADA for this NFT, but how do we do that? I mean, if she sends me the 100 ADA, she has no guarantee that I'll send her the NFT. I could instead keep it or send it to Robertino. But on the other hand, if I send it to her, then I have no guarantee that she will pay me. So this is like one of the best use cases of smart contracts. So I want to design a smart contract where I can do that securely. So the idea is I set up a smart contract. I will send whatever I want to sell to that smart contract. And then I will, for example, in the datum specify the price and the address where I want to get paid. And then I mean, we can, it's simple. I mean, I could make it so that only Karina can get it. But in the context of a DEX, for example, I don't care who pays me as long as I get paid. So the idea is I put my whatever I want to sell into this contract, and the validator checks that this can only be spent if I get paid the money I want. So the validator will check that this can only be unlocked if the price that I set gets paid. I think this is like a very useful thing. And we can also learn a lot from that, I think. Let's try to implement this.
We have a question,
yeah.
Lars.
Yes.
An output can only be consumed by one transaction, but
Yes.
could you use reference? I'm not sure. I'm going to read as it's written. Could you use reference one transaction across multiple transactions? Also, can we reference multiple transactions at once?
I mean, you can't reference transactions. You can only reference UTXOs. But then, yes, I mean, one output can only be consumed by one transaction, but it can be referenced put to many transactions. So many transactions, I mean, here in this reference inputs, the same input can appear in many transactions. The same UTXO can be referenced in many transactions, but it can only be spent by one transaction.
Yeah, and after it's spent, that's it.
That's it. Then it's spent. Then it's gone.
Does that answer the question, Samson? It's clear. Thank you.
Welcome. I should maybe mention, I mean, now that we're at it, at the topic, there we saw this reference script field earlier. So that's one use case for reference inputs. I mean, I did explain that the spending transaction always has to include the actual script. I mean, if the spending transaction tries to spend smart contract inputs, then all the scripts for those smart contract inputs have to be included in the transaction. So the node that validates and runs the scripts gets the scripts from the transaction itself. So it checks that the script hashes to the right hash and then executes it. So the person that wants to spend a smart contract input has to include the script in the transaction. And of course, these scripts can be relatively big, which makes these transactions expensive. And it can lead to a lot of redundancy. If you have a smart contract that's used thousands of times on the blockchain, like for example, for DEX, like a order contract, then every time somebody wants to fill this order, he would include the same contract in the transaction. So that's a lot of duplication and unnecessary bloating of the blockchain. So that's why in this Plutus version 2, when reference inputs were introduced, one of the use cases is that you can actually attach a script to an output. So if we look at the TX out again, so when I explained the EUTXO model, I mentioned address, value, and optional datum. But there's a new addition now. So now there's a fourth thing that can be attached to an output, and that's so-called reference script. And then if that is the case, if you have an output where it's attached, then you can make use of that for scripts. So instead of so if somebody has put a certain Plutus script attached to some output, then a transaction can use that output as a reference input, and then it doesn't need to include the script in the transaction. So it can just reference it. So the use case would be in my example of the DEX. If you have this popular order contract that lots of people want to use, spend from, then the project that creates the DEX could create such an output and attach the order script as a reference script to this output. And then everybody that wants to spend from that script, instead of including the big script in the transaction, could just reference that output. And so that makes the spending transaction much smaller. On the other hand, of course, the project or somebody has to put that output there, and that is relatively costly. So that's it's not the end of the world, but it's something like 15 ADA or so, or 20 ADA, depending on the script size. So it's a relatively significant amount. But the idea, of course, you have to put it there once and then it stays there forever. I mean, can be some debate where you should put this output. I mean, at what address? And I normally recommend to put it at something like the burn address. So where it's guaranteed to stay there forever. So the output can never be removed again. And people can rely on the fact that it will always be there and they can securely reference it in their transactions and be assured that that reference will never disappear. Right, so that's one use case for these reference inputs. I'm not sure whether we want to see an example for that. We could. I mean, there are lots of things to talk about, but let's see. Right, are there any more questions?
Not so far.
Okay, then let me just get out of here, get to the on-chain part, and take one of these, let's say the custom types one, and copy it and call it atomic. And let me change the edit here. Reload and be very careful not to do rebuild container this time. Oh no. Should I do that? No, then I think that's not a good idea.
I think you can ignore it.
Yeah, don't want to recompile Plutus everything again. Okay, now I can go there. So this is now more like a walkthrough example, so it's a bit more involved, but I hope it's also much more interesting actually, because it's something to actually use. Right. I think we don't need this because I can use Atlas. Right. So we want, so again, so the idea is design a smart contract where somebody can put some value in there and specify a price and an address. And then that value can only be unlocked if somebody pays that price to that address. So that's the idea. So first question is what datum and redeemer be? And so basically I said specified date, address and what did I say? Address and price. So that is typically what should go into the datum. I mean, a potential buyer must be able to look up the information. So that belongs into the datum. For redeemer in this, I mean, at least in this first iteration of the example, we don't need anything because, I mean, there's only one thing you can possibly do. I mean, you pay the price. So, right. So let's call it atomic datum. Atomic datum, so address. And atomic datum price, which is a value. Okay, so far so good. And let me just open a REPL as well, because it's always a good idea to keep your code compiling at all times. Right. So now we will need this instance for it. So atomic datum. Right. Okay, so far so good. Now I basically have my atomic or make atomic validator. So my datum type is now atomic datum. For the time being, my redeemer type is unit. And then I have script context and bool. So this is what I want to write. Atomic datum, unit, context. Or I can also script. So let's just, I mean, for okay, I need wildcards. Sorry. Okay. Why is bool not there? It says bool. Oh, true. Sorry. Right. Okay. This is basically that. And I can already do this. I mean, I haven't written this yet, but wrap validator. From there now. Oh yeah, there's some. Oh, that's why I did it like this here. I don't know. That's a bit weird. Sometimes it works to do it directly there, but sometimes it doesn't. So I think this is one of the cases where it does. So you can't do that in the Oxford brackets or is it because I didn't inline this thing?
If you inline,
Yes.
Yeah. Okay. Inlineable. Nope.
and if you use a where clause, that sometimes helps. Like inside
Where?
a where.
Here.
Yeah.
Okay, this seems to work like this. Okay, fine. Just wanted to get the boilerplate out of the way.
That's a templates Haskell thing, not a Plutus thing.
Yes, yes. So it's sometimes a bit weird. Yeah, okay, so far so good. So I now have this atomic validator. Yeah, there is no show instance. Fine. So now, of course, I mean, this is now stupid. So I need to implement this. So what did we say? So it can be unlocked if somebody pays the price to the specified address. So that's the condition. So how do we know that? I mean, if we look at this, so we want, I mean, so some transaction tries to spend this. So the UTXO sitting at this atomic address will sit there and the transaction tries to consume it. And I mean, the condition, what the validator should check is that the seller basically gets paid. So there must be an output to the seller address that contains at least the specified price. So that's what we need to check. So we must check the outputs. So let's do this. I think there's even something I never know. Let me just, sorry, any or something. I'll just repeat that. If I have the Plutus TX valued, is there any?
And you want all to be true, right?
No, I want one output to be go to contain the price.
Okay.
So I think it's any. Right. So I want to check that at least one output pays the price to the address. So I think any is fine. So any. Okay, then the condition. So I do this now, and then now the outputs, and the outputs are tx info. I always forget these names. So what is it called? Sorry, just go back. Script context tx info. So I want the script context tx info and then the tx info outputs of that. So tx, sorry. tx info outputs of that. And why is any complaining? Because I restrictively okay, and of course I must do this. Yes, right. So the any function just, I mean, that also exists in normal Haskell prelude. So it takes, for example, a list and a predicate, and then it returns true if an element in the list satisfies the predicate. So if I have, so this is the normal Haskell prelude. So for example, I can do prelude any even. I now have to qualify it because I am using this no implicit prelude. So the prelude is not in scope like normally in Haskell. It's true, but if everything is odd, then it's false. So yeah, that's what any does. And the Plutus TX version of any is the same. So I want to check that there's an output of the transaction that pays the price to the address. Right. And just to warn you, yeah, anyway, we'll talk about that. Okay, so P. So, I mean, one of the points is this is just normal Haskell, right? I mean, this has not, I mean, the types are Plutus specific, but I mean, you still write Haskell code, more or less. I mean, yes, you write Haskell code, which then gets compiled to Plutus. So we have a TX out and want a bool. Right. So let's look at this TX out type again. So we are looking for an output that goes to the specified address and where the value is the price or is at least the price. I mean, you can debate about that, whether you want to check that it's exactly the price or at least the price. But my point is, I mean, this contract is basically written by the seller. The seller wants to protect his money. The seller puts his money in there. So the contract should look after the interest of the seller because he puts his money or whatever he wants to sell on the line by parking it in that smart contract. The buyer, I mean, nobody forces him to interact with the smart contract. So therefore, I always tend to, I mean, I always ask myself, I mean, whose interest is the smart contract supposed to protect? In this case, it's the interest of the seller. The seller wants to be guaranteed that he gets paid. And that means the seller doesn't care whether he gets overpaid. He just wants to get paid. So I would check that the price is at least the specified one. So we must check that the address is the specified one. So tx out address equals the given one, which we called ad address. And probably is and imported. Probably I need to import and. Let me just write true. Yeah, and is not. I need to import and. That's also in the Plutus prelude. Right. And now I must check the tx out value, and it's supposed to be greater. I mean, but greater or equal doesn't exist. We'll talk about that in a second. So I want to write something like this. But we haven't talked about the value type yet. Not really. So and we can't really talk about this before we understand native tokens. The point is, I mean, it's not just a number. I mean, if there was just ADA, then a value would just be a number, the amount of ADA. But we have these native tokens. So a value can be a mixture of ADA and NFTs and all sorts of native tokens. So it's like a bag of coins of potentially different currencies. And each currency on Cardano is given by two pieces of data, a so-called currency symbol and a token name. So when we talk about native tokens later today on Monday, we will explain that. But for now, you can just take it as a given that each currency has these two pieces. And ADA is no exception. So ADA also has these two pieces, but currency symbol and token name for ADA are just the empty string, basically. But that's a special case. And so a value is represented as a map of a map. So yeah, it's a map of maps, but that's equivalent to basically a map of pairs from currency symbol and token name to integer. So it's basically a list that tells you, okay, how much of which currency do you have in this value? And I always forget, but I mean, there must be something like comparing them. That's probably, I mean, there are all these weird types here with semi-lattice and meet semi-lattice, and do you know, Robertino or Karina, what I'm looking for? I need something like greater or equal for values.
We have, right.
Or is it there?
I think we have no, we have equality. But maybe for inequality, you might need to extract the actual value.
No, I think I'm pretty sure there is GEQ greater or equal or something. I just always forget.
Yeah, I think it's this. Yeah,
Let me just check
It's-
this.
it's like you said, Lars. I can send you
Uh-huh.
in the chat.
Thank you. I can look. I just wanted to, I mean, where is that actually defined? I always get confused. So it's not in Plutus TX.
Right, it's in Plutus apps.
It's Plutus apps, yeah. I sent
Plutus
you
apps.
the link in the chat.
Let me check the chat. Chat.
Plutus script utils value.
Yeah, just a second. Yeah, exactly. For some reason, the stupid chat doesn't.
Okay, in Slack, I think I can send you.
Okay. And Slack. Don't have Slack open right now.
Okay, maybe.
But for
Yes.
some reason, the stupid chat window doesn't work for me.
So it's Plutus apps in Plutus script
Okay.
utils.
Plutus, yeah, the module is Plutus script utils in Plutus apps, but we don't have access to Plutus apps.
Right, but isn't it in Plutus Ledger API, or I mean the second version, but the first version should also be fine. No, that's just fine. Just a second. So it's only in Plutus apps, you say?
As far as, I mean, the module we found is in Plutus apps. So I'm not sure
Okay.
if maybe it got extracted at some point.
Yeah, let me just. It's much better than it used to be. I mean, they simplified this quite a lot, but it's still sometimes a pain to find what is defined where. So, but I had that the other day, didn't I? Hang on. Let's be like not stupid about this. So let me first import Plutus TX. No, actually, Plutus Ledger API v2. Okay, there's just that stuff. And v1 or common. That and v1. Right, there's this thing value. So, and now let's browse. Okay, there we go. So it's in there. So there's Plutus Ledger API v1 value. And in there is, for example, GEQ, greater or equal. And I should just mention for the less mathematically inclined of you. So, I mean, of course, two numbers, two integers, you can always compare. I mean, it's if you have two numbers, there are only three possibilities. The first is smaller than the second, the first is larger than the second, or the two are equal. If you have this bag of coins, then that's no longer true. I mean, you can have two values that are not comparable. I mean, if you have like the one value is 3 ADA and the other value is 1 NFT, then neither is greater or smaller than the other. They are just incomparable. So this is I mean, mathematicians call that a partial order, whereas what you're used to from numbers is a total order. But nevertheless, so there's this GEQ and it does the right thing. So that is true if basically each coin contained in the second one is also in the first one with at least the same amount or larger. Right. For some reason, I now have this stupid chat window and I can't close it again. Don't know what that was on my screen. I mean, it opened this meeting chat, but I can't close it. And now it's blocking my browser window and now I can't do anything anymore. Let me just minimize it. Okay, anyway. Right. So we need this Plutus ledger. Plutus ledger v1 value GEQ function. Why is it complaining there? Okay, because I'm not using it at the moment. So instead of this, I need GEQ. Right. So this is, let me just warn you, this is not the final version, but this is reasonable, right? Okay. So now that should hopefully still compile, and now we can get rid of the stuff we don't need. Okay. Right. So now what off-chain code do we need? Somebody wants to set up such a sale and somebody wants to buy something. Right. And then, of course, we have all sorts of options. Right. But we can talk about that. So this is, I mean, this is a smart contract. But I mean, I will later change that a bit. But for now, I mean, does everybody or does anybody think this is not correct or is not reasonable?
No comments.
Okay. Okay, so then let's go to the off-chain side. And let me also import this atomic.
PM says, strange to see value is not an instance of ORD.
Yes. But odd is like what mathematicians call a total order. So you should always be able to implement, yeah, that's because of this bag of coin thing. I mean, with odd implies that, I mean, the definition of odd is that if you have two, I mean, if you have a type that implements odd, you have two values x and y of that type, then one of the three things is always true. X is less than y, x equals y, or x is greater than y. But for values, that's not true, because you can have like bags of coins that are incomparable. I mean, you could have one that, I mean, can have something like, I mean, one value is 3 ADA plus 7 whatever Kenya coins, and y is 5 ADA and 3 Kenya coins and 1 Nairobi NFT or something. And it doesn't make sense to say this x is less than y or y is less than x. They are just not comparable. And that's why it's not an instance of odd. But nevertheless, it makes sense to say greater or equal. So in this case, neither is greater or equal than the other. But for example, if you had 2 here, then y would be greater or equal than x. Or also if you had 3 there. So greater or equal means for each in the smaller one, each currency in the smaller one, the amount is that same currency is also contained in the other one with a quantity that's at least as big. So what you would intuitively think.
Yes.
But yes, makes things a bit complicated for, I mean, values on Cardano. Right. Okay. So now we have this atomic thing. So let me switch here. Okay. Okay, let's first do the boring stuff. So atomic validator. It's now atomic validator. Atomic address. Okie dokie. Now somebody wants to place or create atomic or whatever we call it. Let's call it place atomic. So let me copy this. Okay, so what should the inputs be? So 1 is definitely the value, so that's what you want to sell. Do we need other inputs? I mean, we must create the datum. So and the datum contains the address and the price. So definitely the price must be, so let's say, I mean, whatever we call it, item is the value we're selling. I don't know whether that's a good word. Let's call it to sell. And we need the price. Now, in order to create this datum, we also need the address where we want to get paid. And now we have options. I mean, we could explicitly ask for the address. However, we can also basically, because we are in this GYTX monad, we are in a context where we know our own address, or at least our, yes, I think so. So let me just, so I mean, we have this monad, and actually we are now in the GYTX monad. So for example, we have own addresses. So we could also, so basically in the context of the monad, we are aware of our own address. So we could simplify this and just pick one of those. So let's just to get some familiarity with Atlas and its capabilities, pick this approach. So can you still hear me? Yeah, sorry. I thought for a second I froze there. So let's do this. So this address, address is now a bad name. Let's call it contract address or something. This is now the atomic address. And now we want to determine our own address. So let's just be quick and dirty. It's a list which could be empty. So let's just use head own addresses. This is normally always a very bad idea because head is one of the most hated functions in the Haskell prelude because it's a partial function. So if you have an empty list, it just errors out. And we could do this better. We could do a case whether it's an empty list or not, and then throw an exception. But I think it's also fine in this example to just have an error in that case. We can also, let's do it like that. This GYTX query monad actually also implements monad error of this GYTX monad exception. So alternatively, we could also throw an exception, which would probably be the cleaner solution. But for simplicity's sake, let's do it like this now. Okay, so now we have all the stuff we need to actually create our datum. So we can call it D. So that's atomic datum. And we had this atomic AD address. So that's where we want to get paid. So that's our own address. And we had this atomic AD price, which was specified as parameter, an argument to the function. Why is it complaining? Because own address is a genius yield address, and GY, comes from Atlas. So this is from Atlas, and value is also not the right type. So these are the GY types that Atlas uses, but in the datum we need Plutus types. But as I mentioned before, there are conversion functions. So there is address to Plutus, and there is value to Plutus. Okay, so that gives us the datum. Now, out address is the what now called contract address. Datum, now it's no longer unit, so now it's the datum we just defined. We can use inline datum again. And the value is this to cell thing. We don't make use of reference scripts. And what's the problem there? Oh, it seems that already exists. So let's call it own address prime. And then probably I also don't have this head problem. What's the issue there now? Whatever. Okay. Right. So this allows us to place. And now I want something to place. So I need something. I could use it, of course, but that's boring. So let's see. And maybe let's in the beginning not use my fancy Nairobi token. Let's use something. I don't know. I have this thing, for example. Right. So let me just look up the address. So that was this address. Many windows in the way. And after I do this, we can have a break again. Just prepare this copy. So I just use my wallet to send something. And now I want to not just send ADA, I want to use some just to try it out. Whatever. I have this Hubert token here. So let's send, I don't know, 10. Okay, let me switch back to my terminal and check what I have at this address. At the moment, it hasn't arrived yet. Okay, now here it is. So here we see the output, so Loveless, and now 10 of this thing. So it had this human readable name Hubert in the wallet, but that doesn't have to be human readable. It's just a byte string. Therefore, the Cardano CLI, I explained that the tokens are given by, I mean, these two parts, currency symbol and token name, and they are displayed here, separated by a dot. And this is now just the hex version of Hubert. So if you convert this hex to ASCII, then you would get Hubert again. So this is the UTXO. So here we see for the first time, like properly, a value that's not just ADA. So it's one of these bags of coins. So we have 1.04 ADA and 10 of this custom currency. So I now have that. And now somehow I want to specify that. And so let's see. So, so let me do overloaded strings again. And I did this, I mean, in order to create values, I used this value singleton before, which takes the so-called asset class, an integer, and creates a value. Asset class is just a combination of, we can look at it. So asset class is either Loveless, which I used before, or it's a token given by these two parts. But luckily, it's also, just a second. It also implements a string. So I can just use this form here, I think, to specify that. So if I do this and ask for the type of that, so yes. Oh, and then here it even displays it again as Hubert. Right, so that's that. So in order to construct my value, I can do use this value singleton, and now this and 10. So that works. Okay, and now I can actually call this, or I could if I had the O function for it already. So let me copy paste this. What do I need? The two file paths and the two values. To sell and price. So now here it's now placed atomic to sell and price. I should really somehow abstract this away, that I don't always have to copy paste. Very bad style, but okay, let's call it atomic. Okay, let me reload. Now my V is gone, of course. Okay, so now I can try this. Place atomic IO. Config, let's use block crossed again. user S key. Now the value is this V, what I want to sell. I want to sell my 10 Huberts. And now I can specify price. So let's, whatever. Let's say I want 1,000 ADA for that. Okay. And here the here we see now this is the transaction, and we also see so this is my address. So no sorry that no this is not the transaction. That is the transaction where I from my Nami wallet sent it. So I sent from my Nami wallet 10 Hubert tokens to this address. But now must wait until there are 20 transactions. But now I'm again at the point where I wonder whether it worked. So hopefully, but this looks good. There we go. Right. So I paid 1.48 ADA. So that's not all fees. Part of that is also deposit. I said before on Cardano, each UTXO must come with a so-called minimal deposit in ADA. And that's something like 1.1, 1.2. It depends a bit on what is there. So now, because I created this UTXO, the Hubert coins, so part of that is deposit. And then the transaction fees. And we have the Hubert there. And if you look at the smart contract address, then sorry, if I look at transaction and the UTXOs, right. So this is the UTXO I now created. So this is the smart contract, and this is the datum. And if we inspect it, then it should somehow be my address. I mean, where I want to be paid. So this is now in a different format. It's in like CBOR. So it's not this address underscore format. And somewhere the price should also be specified. Which, I think my window is in the way. Sorry. I'm a bit confused now because I specified a million ADA or something, right? 1,000 ADA. I don't see that anywhere there. So maybe I'm wrong. This is a bit weird. Not sure whether I'm looking at the right datum actually. That should be, I mean, it's this one. I'm a bit confused now. I was expecting that one should be able to see the price that I specified. Maybe there's something wrong with this inspector. I'm not sure. But we can see when we try to, or I made a mistake and I specified the datum in the code. It looks okay, right? I called it with, let's see. I mean, we see when we try to buy it, but maybe we should have another break, maybe until, I don't know, 5:05.
Yeah.
Okay. Yeah.
Okay. Talk to you then. Right. So now what next? And now somebody wants to buy it, but in order to buy something, I mean, you first need to know what is there to buy. So we should have a function that basically shows us everything on offer. at that address. So let's try that next. So like whatever, scan atomic. So that's a query. So it doesn't create any transactions, it just inspects the blockchain. So what should we should get a list of, for example, that depends now what we want. But for example, we can say pairs of output references, or let's say a map. Let's say a map from out references. So there can, of course, be potentially more things on offer, and these datums. And and we need also what is on offer, which is not contained in the datum. So what is on offer, and these datums. And map is not in scope. What data map? Doesn't matter. No, I think we have never talked about that. So data.map, I've always used data.map, not to confuse everyone. There are actually two versions. There's the normal data.map and then data.map strict. And strict, the only difference is that, it's related to laziness. So in the normal version, the values can be like thunks that are not evaluated, and in the strict version, everything is evaluated. And I prefer the strict version, but the API is exactly the same. So you work with it exactly the same. But I think Atlas normally leans towards the strict version. Therefore, I want to use that as well. So because it's confusing if in the same code you use both. And I think it's not yet, I must add containers to the dependencies. Right, so let's do this again. I see I make far slower progress than I thought, but I nevertheless hope that this example is like insightful or helpful. Right, let's reload. Okay. Okay. Right. So first we need to somehow, get all the UTXOs at this address, at the address of the contract. And if we look again at GYTX query monad, what sorry, what it can do, then one of the things it can do is this UTXOs at address. So let's get the address. And then UTXOs at address, contract address. Okay, so what's this UTXOs? What types? You could think it's just a list of UTXOs, but actually it's its own type. But you can get a list of UTXOs from it. So internally, but that's not exported the constructor. It's a map from output refs to basically all the information you want about the UTXO. So it has the address, the value, the datum, and optionally a reference script. But we can also browse Genius yield types UTXO. and there are all sorts of things. And one is this one. And this is appropriate right now. So it's called wither. So given a function from one UTXO to in some applicative. So for that applicative, we will use this monad we are in. So you can think M, maybe A. Given a bunch of UTXOs, we get in the same monad a map from genesial TX outers to A, which is exactly what we want. We want to get such a map. So this is like the appropriate function. The maybe is because maybe we don't want to use all the UTXOs. As I said before, everybody at any time can send anything anywhere on Cardano. So anybody can send something there. So for example, people can send stuff there without datum or where the datum is of a different type. But I'm only interested in those UTXOs at my script address that have the correct type, this atomic datum type. So this is exactly what I want. So I want this wither UTXO, wither UTXOs with an appropriate function, and the UTXOs I just looked up. So wither UTXOs, appropriate function, and the UTX, sorry, for some reason my editor sometimes acts up, appropriate function, and the UTXOs I just looked up. So in this appropriate function must go from one UTXO to this type. So do this. F from one UTXO to maybe value atomic datum. So what is now this thing? Okay. So I can ask for information on this. So this is one UTXO. And this is what we would expect. So it's the reference, the address, the value, and the output datum, and the reference script. So the value I want, so that's good, I have that already. And now the datum. I mean, this is just GY output datum, which can be anything, but I'm only interested in the ones that have the right type. So let's ask for information on GY out datum. And that can either be no datum or just a hash or inline. So, and I think there's also something, look up datum. Right. So I always forget there are there's UTXO datum as well. Right. This is what we want now. So given a UTXO, I can actually for anything that implements from data, so I mean the problem is there are obviously three cases, right? It could just have a datum hash, it could have an inline datum, or it could have datum hash, but then the datum in the transaction. And you can do that by, so normally you always have to, I mean, of course, I could just assume that it's inline datum. I mean, that would be one option. But I can also use this higher level function UTXO datum, which basically does that for me. So it handles the three cases, and gives me a unified interface. So I just give it a UTXO, and then it tells me either it can't deserialize it or it can't look up the datum because it doesn't find the datum, that's just a hash. And if there's the datum, it tries to deserialize it to an A, and if that fails, it will also give me an error. That's like the most robust version I can use now. And I should give this a name. Oh. So I do this UXO UTXO datum, this function, and I apply it to my UTXO. And if I get a left error, then I'm not interested in this UTXO. And if I get a right address. Oh, actually, I see I get the value there as well. So I don't even need this record syntax because I have the value here in this return type as well. Then I just return just what do I need? I need the value and the datum. Okay, and why is because it's two things, it's not three, it's a pair. This should now work. Oh no, it's three, sorry. What did I now do wrong? Okay. It's sorry, it's in the monad. Sorry. We are in this monadic context, so it's this. Right, so this error now went away, and this is pure nothing. And this UTXO datum also is in the monad. Sorry about that. So I have to do, first I have to call that. It's not a pure function, it happens in the monad. So this and then case E of, and now my two cases. And so now I can just do that. Now, sorry, obviously I'm confused. This is correct. Oh yeah, that is scope type variable. It doesn't, I mean, we have discussed this problem before, that even though I also call it M, still, yeah, oh, sorry. Even though I also call it M, it doesn't know that I'm talking about the same M. So now, okay, so that's that. We can try that out. So scan atomic IO or something. And actually, we don't need the full, but I can do exactly the same. Just a second. I mean, until now, we have always used this run gytx thing monad when we wanted to actually execute it. And we needed all of this. But now we have only this a query. We don't want to create a transaction. We are just scanning the blockchain. So in that case, I mean, there's a simpler function basically. But nevertheless, we need the network ID and we need the providers. So let's just first copy paste this. And scan. So we don't need any other arguments except for, we don't need our own address because it just scans the blockchain. It has nothing to do with us. The return type is this map from gytx outref to, what was it, a value and this atomic datum. Right. So for this, we don't need our own credentials. We just need, and the config file, we only need to get to the network ID basically. And of course, no, we need the providers as well. We need access to the blockchain, of course. but we don't need our own key for this. Don't need that. Okay, and now instead of using this here, I can just use this run gytx, what was it? gytx query monad node. And I need to provide the network ID, which I have. I need to recognize the providers that I have. And I need a monadic computation, and that's this scan atomic. Okay, so that should work. Can also, I don't need this map stuff, but yeah, it doesn't matter. Maybe, probably I will need it later. And now I can try this out. So hopefully this works. I'm a little bit worried because the datum looked weird before because this price wasn't displayed. But let's hope for the best. Let's use block frost. Right, so it doesn't do anything. Hang on. Okay. But I can do, for example, map size M. Okay, so it has found one. I just can't display it. But of course, that's an easy fix. I just go back and do the derive show here. I can't because that's what now? Okay. Now I have to reload for this change to take effect. Okay, and now if I run this again, now it has a show instance, so now it should, okay, right. And so we see this is the result. So this is the reference where this one UTXO sits. We see the value in there, so what's on sale. So that's this, I mean, sorry, it's this UBER token, 10 of those, but we see there's also some ADA, so that's the minimum deposit. So this is 1.3 ADA. And then we see the datum here. So this is the datum where I want to get paid to and the price. So the price is correctly there, the 1000 ADA. So I still don't know why somehow the inspector doesn't show it. Maybe I just didn't look correctly, but it's there. So our function was able to look that up. Of course, this is ugly. If I now wanted to write like a proper application, I obviously would display that nicely. Or in a web application, you display everything that's on offer. But the point is just that, I mean, this is an example of how to query the blockchain. So instead of looking in the Explorer, I can now use this function to actually look what's there. And now what's missing is actually buying stuff. So let's call it buy atomic or something. And so yeah, let's do that. Sorry, I'm in the wrong here. So now we can place, we can scan. Let's do buy. So this is now, we want a transaction out of it that actually does the buying. So now we're in this GYTX monad again. So what should the input be? I mean, we must specify what we want to buy. So for example, buy its TX outref. Okay. And then we get a M GYTX skeleton Plutus v2 out of that. Right. So we have this reference. So first of all, we must look up the price. And we already know how to do that. I mean, we did that in this helper function here. But unfortunately, this is inaccessible to us now. So I should move that to the top level and give it a proper name, like atomic datum or something. And then, of course, here I must use this atomic datum. And now I wouldn't have needed all this. And with the scope type variables, okay, anyway. So first step is I take my reference and look up the datum. So atomic datum ref. And now, of course, if that's nothing, then this UTXO doesn't correspond to a valid order. Maybe it's some arbitrary, maybe it's even at the wrong address, or actually, I mean, I should check here that, I mean, one thing I forgot, I actually should make sure that the address is correct. I mean, here I'm guaranteed. In this case, I didn't check that before because here I use this UTXO set address. So all the UTXOs that I get returned here are obviously are at that address. I mean, that's what this function does. It looks up all the UTXOs at that address. But if I use this function standalone for an arbitrary UTXO, the address is not guaranteed. So I actually should check that. So I should do address contract, sorry, atomic address. And then I should make sure that, so I should actually check the address field as well. And only if that is the correct address, do I do this, and otherwise also nothing. As I said, if I call it via this scan atomic function, this check is unnecessary because all of the UTXOs will be at that address, because that's exactly where I looked. But if I have an arbitrary UTXO, I need this check. Anyway, so now I can be sure, or if this is nothing, so it was an invalid UTXO. And now let me again, sorry, I think I also need MTL so that I can throw errors. Let me check. Let me get out there again, reload it. Okay. Of course, that's an error, obviously. Must import something for this. Where am I? The editor support is not there yet. But I know it's probably that's also exported by Atlas, but doesn't matter. Error. Load. And of course, I must say what error to throw. But so it's this GY TX. exception. I'm just checking whether there are all sorts of specific exceptions. There's also this application exception where you can basically throw an arbitrary exception. So that should work now. I mean, normally I should define like a proper exception type here, but now I don't want to go into that. So GY application exception, and now I can do something like user error, whatever, invalid UTXO or something. That should work. All right. This expects a UTXO and I only have a ref. So I first must get the UTXO. But we are covered for that because there is something UTXO at TXOutRef, which is exactly right. And there's also a primed version. I mean, this maybe version, if that reference there is no UTXO, it would give a nothing, but there's also a primed version which throws an exception in that case. So that's good. UTXO ref, and here UTXO. Okay. And now why it's now complaining? Okay, because I don't have the just case. So if all goes well, then I get my value, which is what's to sell, and I get the datum. And that's atomic, or yeah, datum, which is atomic datum. Okay. And now I must now I must construct my transaction. Now I have the necessary information, I think. Okay. So what do I want to do? I mean, now it's interesting because now I mean, until in the examples we had until now, I always specified one output or one input, but now I need to specify two. I must specify one input, namely that I want to spend this UTXO, and I must specify one output, namely the payment that I want to make. So this is now, I mean, we can try with pure. So must have input. And let me just copy one of the must have inputs from before. Just give me 1 second. Okay, sorry. Let me just look where we had one before. Must have output. Oh, here, right. Let me just copy that. Okay. So we have the ref. So that's by coincidence already the right name. So that's the UTXO we want to input into our transaction. Now for datum and redeemer. So the datum is this D that I just looked up. But it has the wrong type because D has this. So, I mean, we can define it here. That's datum from Plutus data D. And redeemer is as before, because we didn't make use of the redeemer. We can just use unit, or we must use unit. Okay, what it's complaining about there. Okay, I see. I can't, there's something isgy API error. So I can't just use an IO exception. So that's a bit annoying. It's a bit difficult to, but I don't want to waste time with that now. I mean, I just say error invalid. So then I wouldn't have needed to import MTL and so on if I don't use throw anyway, but doesn't matter. I mean, we should do that properly. There is a way in Atlas to like define custom exceptions, but I don't want to worry about that now. Rather get on with it. Okay, so that's the input. But now, of course, we also must make the payment. So we have this must have input. And now I add a, well, let me format it nicer. And now I also want must have output for the payment. I mean, I don't really want to, but if I don't, then it will fail because the smart contract will forbid it if I don't pay. Okay. Must have output. Okay. The address we don't have yet. So let's look it up somewhere, like here. Datum, nothing because it's the payment. So we don't need a datum. Value is the price, and the price we can look up in the datum here. So we can do the AD it's atomic AD price. But this is now a Plutus price, and of course here we are using Atlas, so we need value from Plutus, which unfortunately, okay. So there's also a version that can throw an exception because, I mean, one annoying thing with these types is that they are not 100% compatible. So sometimes something can go wrong. I mean, nothing should go wrong during conversion, but it can. So we have to like price value from Plutus prime atomic AD price. What's it complaining about now? A bit confused. Let me just not use this record stuff. Maybe it's that. And just do it explicitly. Okay, so we have price. And this was a mistake, of course, this contract address, because I don't, that output is not supposed to go to the contract, it's supposed to go to the seller. So that's, I must look that up in the datum as well. So that would be address from Plutus, which also can go wrong. So and here seller. This is address from Plutus B seller. Okay, and this I don't need, it seems. Because that's automatically then. What's complaining? Ah, yeah. Sorry, it's of course atomic AD address. Okay, looking good. And now I can buy atomic IO. So let me just one of these. by atomic IO. So what do I need? The two files, the reference I want to actually buy, and that's that. So rough. So this is all the boilerplate. I really should, never mind. Okay, now it's atomic by ref. Why is that complaining?
IO. Atomic IO.
No, by atomic. Sorry, no, I'm. It's called by IO, right? Okay. Not sure that I have to restart. Okay, so that should be it. So now one should be able to actually buy the stuff if it's still there, if nobody bought it in the meantime. So let's first do the scan again. Okay, it's still there. And this is the reference. So now let's try the buy atomic IO. I mean, of course, it would be more fun if somebody else bought it, if I don't have to buy it back. But let's just do this now to see whether in principle it works. So I config first keys user S key, and now I need the reference, so that I can get from here #0, and probably it will give an error because of overloaded strings. Yeah, of course. So I have to set -x overloaded strings and run that again. Okay. So what did I do wrong? Okay, so it's invalid, which is weird because it wasn't invalid before. I mean, I with the scan I get it. So how can it be invalid now? Did I specify the?
There's a point in between
Oh. I see. Yes. How did that get there? Whatever.
That's a mystery.
No, probably I made a mistake with. Look at the scan again. I don't know, it's completely wrong somehow. Oh yeah, I double
you
click, but
copied the
yeah. I mean, I'm in the REPL now. I can't just double click on stuff. I need to explicitly copy it. So it was still something I copied to my clipboard earlier. Okay, looking better. Or script error, missing script. So I probably attached the wrong script again somewhere because I just copy pasted stuff. That would be here. Oh yeah, it's the 42 validator. But of course, I need the atomic validator. Right. Let's try this again. What now?
Did you reload?
you need reload, yeah.
I didn't, of course not. Right. So now I should have the, I mean, if we look at this again, at this address. So this is still the one where I gave the tokens away. So I have to be patient again. Okay. And I got my Hubert back. This is now a bit stupid, of course, because I mean, I'm the buyer and the seller. But if we look at the UTXO with the outputs, then we see that the 1,000 ADA were paid. And Hubert, so this is the payment. And this is like what I got, and this is the change. And normally, of course, I mean, in this example, now they both go to the same address because buyer and seller were the same. But of course, normally it would be different. So far, so good. So that works. Right. Any questions at this point?
Not so far.
Actually, I mean, I wanted to be much faster. It always takes longer than I thought. But I think it was important to have like a bit more realistic example because this is like actually useful. I mean, you could actually use that, and it could be like the foundation for an actual project where you like a platform where people can sell stuff, for example. However, there is a very big, I mean, there are one small and one big problem with this. The small problem is that if nobody buys your shit, you don't get it back. So, I mean, the only way to get it back is if somebody buys it. So if nobody buys it, then you have to buy it yourself. So you somehow, which normally, I mean, this example was fine. I mean, I bought it myself. But I mean, if you ask for a very large sum, maybe, or some unique token or whatever that you don't have, then I mean, it would be gone. So what we should do is actually allow a second, allow something, and maybe we can still do that today if I'm fast. Not sure. So what we should do is we should allow the seller to cancel this. So, I mean, we have this condition that we check whether it was paid, but we should add another condition if it's signed, for example, if the transaction is signed by the seller himself, and we can figure out the seller, or we could add that to the datum actually, by whom it should be signed, then we don't check whether there's payment. Then we just automatically accept it. So that's one thing. So that the seller can get it back. However, there's a much bigger problem with this. I'm not sure whether anybody can spot this because it's possible to steal money from this contract. Or at least to cheat by, I mean, that's wrong, putting it wrong. It's possible to basically cheat and not pay. Can anybody spot how? Right, this is the so-called the infamous double satisfaction problem. So it's fine as long as there's only, if I only sell one item at a time, like I did now. I mean, there was only this one offer that this one offer that I made, this 50 tokens. And then it's good, all good. The problem comes if I make two orders. If let's say I do two orders, so two orders with the same address. So for example, I want to sell these Uber tokens and then also another token. And then the problem is that a buyer can create a transaction, one transaction, in which he buys both the offers in the same transaction. So he uses two script inputs, one for each offer, but makes only one payment to the correct address. And the problem is, I mean, the way it works. So we have, I mean, I probably should somehow. double. So let's say we have, I mean, it's at this atomic, we have Lars, whatever offers 50H, price 1000 ADA. And now I have a second one there, atomic, Lars offers whatever, 30 something, and price also whatever, let's say 800 ADA. So if I now construct one transaction paying 1000 ADA to Lars. So I construct a transaction that has these two as input and then one output to me. I mean, I shouldn't say Lars. I mean, I should say seller. Let's say some other person has placed these two offers. He offers 50 tokens of some sort and 30 tokens of some other sort. And one price is 1000 ADA, one price is 800 ADA. So I could now create one transaction with two inputs, these two inputs, and I only have one payment output to the seller over 1000 ADA. And now what will the Cardano node do when it validates? Well, it goes through all the inputs and runs all the scripts if it's a script input and checks whether the scripts say it's okay. So it will come to this input, see, okay, that's a Plutus address, so I have to run a script. So it will execute the script. And what will the script do? The script checks that there is an output to this transaction going to the seller with a value that's greater or equal the price. So it finds this one output going to the seller, and that's greater, and the value of that output is 1000 is greater or equal than 1000. So the first validator is happy. And then the node executes the second validator. The second validator is the same thing. It checks the outputs, checks whether finds this one, sees okay, it's to the right address, and 1000 is greater or equal 800. So the second validator is also happy. So both are happy. The transaction goes through, but in the end, of course, I cheated the seller out of 800 ADA. That's the so-called double satisfaction problem. And that's quite subtle. And it's not so obvious how to solve it. So, I mean, the problem is that these validators, I would say the root cause of the problem is that, by the way, how the EUTXO model works, these validators run completely independently. So the one is not aware of what the other does. I mean, you should think that the one can say, okay, there is an output for me, 1000 ADA, and then that somehow he should be able to signal to the other validator that output, this one, has already been used, whatever used means. But there's no way. I mean, they can't communicate with each other. They run completely independently. So that doesn't work. And I mean, one way would be, for example, the validator could check that there's only one smart contract input going into this transaction. But this is also quite brittle, and it's also not nice because you would like to combine such things. So you would like to buy several offers at the same time in one transaction to combine as much activity as possible into one transaction. And if you think about it, this is also like a problem that can occur outside of Cardano in real life. I mean, if you, for example, you go to, I mean, let's say, whatever, you go to I mean, you have a headache and you go to the doctor and he gives you something, and the next day you fall down the stairs and you strain your ankle. So you go to the same doctor again the next day and he helps you. And I mean, normally doctors don't immediately send an invoice, right? I mean, maybe they do it once a quarter or once a month or whatever. In Germany, they don't do it very quickly. Don't know how it works in Kenya. But so then, like, the doctor sends you two invoices. Let's say one over $1,000, one over $800. expensive doctor. I mean, if you now pay him $1,000, then it's not so clear for the doctor's admin person to find out. I mean, to check that. I mean, he could. I mean, if you checks. I mean, he says, okay, this Lars needs to pay me $1,000, and then he sees in his statements, oh yes, Lars paid me. And then maybe next day he checks the other invoice and says Lars has to pay me $800, and he checks his statements and sees, okay, Lars paid me even $1,000. So I mean, even there it's a bit tricky. And I mean, how that normally works, I think, is, I mean, on an invoice, it doesn't just give you the amount, it normally gives you some sort of invoice number that you are supposed to include when you transfer the money. You are supposed to like reference this reference number, and then the accountant can check that, I mean, this payment is for this invoice. And incidentally, the same solution is possible on Cardano as well. That's actually something I came up with to solve this problem. And I think it's quite well, I mean, a lot of people are using it, I think, and I think it's like secure. So my solution to the problem is to, when you make the payment, not only, I mean, make use of the fact that you can attach a datum to every output, also outputs going to public key addresses, and attach the UTXO ref of the order you are paying for as a datum to this output. So in this example, this offer and this offer would have, and then check that in the smart contract, that there is not only an output to the right address with the right amount, but also one with the correct datum, where the datum is the input we are just validating. And then, and in this example, so that means I would need one payment with datum, the reference of this order, and one payment with datum, the reference of that order. And so I can't cheat by only having one payment output. I need two payment outputs because I need two different datums. So that's the trick. And now, of course, we are out of time and I can't demonstrate that. So maybe I can do that on Monday. There are lots of things still to cover that I wanted to talk about today, like times and parameterized contracts and native tokens. So I'm not really sure whether I should do that on Monday and then we do testing and stablecoins on Thursday, or what we should do. Any suggestions, Robertino, Karina?
I think the fundamentals, like we should cover that, and then, like, for example, if they understand what you're going to explain today and next lesson, I could go over quickly only the smart contracts of the stablecoin, for example, so they understand like the crucial part, and they can explore it later. But if I try to explain a more complicated, the stablecoin, or a more complicated example without strong fundamentals, it's going to be hard.
Right. So on Monday, I just continue with the fundamentals, and then we just see how far we get, whether we can start with testing on Monday or not.
Yes, because I think time is important only for the concept. Yeah.
Yes, I also think it's important to spend time on the fundamentals, right?
Yeah.
Yes, I hope this example is like interesting with the order. I think it's quite interesting. I mean, I personally find it's quite interesting. And as I said, that's actually useful. I mean, this is the problem, this double satisfaction, that's crucial. But once you fix that, it's actually a useful thing that you could turn into a business in principle. I mean, where people can buy and sell stuff on Cardano securely. I mean, it's a nice contract because it's actually very simple and it's very flexible. I mean, it doesn't say it must be ADA or anything. You can sell whatever, NFTs, so you can use it to exchange different tokens. I mean, it's really actually a beautiful contract. The only problem is as it stands now, it's insecure. But as soon as this double satisfaction thing is fixed, then it's fine and quite nice, because then you can also combine like different offers and so on. So are there any questions?
Seems like no.
Yeah, and I think, I mean, it was slow today. I mean, we didn't cover a lot of things, but nevertheless, I think it's important to see at least one non-trivial example. I would say this atomic contract is non-trivial example of all the pieces. And I mean, what is also typical actually is that the on-chain code is normally much shorter. I mean, I wrote much more off-chain code than on-chain code, which is also good because the on-chain code is the security critical one. I mean, you must get that right. Otherwise, you can lose a lot of money. But the off-chain code is not so critical. I mean, the worst thing that happens, I mean, I made lots of mistakes when I wrote it. When I, for example, had this, I mean, still the 42 validator or wherever it was. I mean, here I first had the 42 validator. And I mean, all that happens is that I just can't place my transaction. But that doesn't harm the security of whatever is on chain. So this is not so critical. So that's good. I mean, you can really relax basically writing the off-chain code. Not completely, but I mean, it's far less critical. But that's typical, this division between on-chain, off-chain, that on-chain tends to be much shorter. And also what's also typical, at least in my experience, is that you always have these three types of, I mean, the first examples were too simple, but I think this one is quite realistic. And it's often that you have these three types of, or several types, I mean, there's two types at least of I mean, the query part, where you don't submit any transactions, you just check the situation on the blockchain, depending on what you're interested in. I mean, often you're just interested in one contract, like this Atomic contract now. So often you want to check what's out there. I mean, what UTXOs are there that you're interested in. And it's also typical that you have a function like this one that I called atomic datum, where you get some arbitrary UTXO and you have to check whether it's of interest to you in the right format and so on. So you often have something like this scan atomic to just look at the blockchain. And I mean, typically, of course, I mean, this is now very ugly, the output here, but typically, I mean, it would be at least a terminal UI, or I mean, normally it would be a web UI. So you have a server that implements this, then using something like what Robertino showed you 2 weeks ago when he talked about web development in Haskell, or I mean, doing whatever. You can, I mean, normally, of course, it would be some website, and then it would probably talk. I mean, doesn't have to. I mean, there are other ways, but it could, for example, talk to a server that does this scan atomic thing, and then the website would nicely display it. I mean, of course, not in an ugly format like that, but nicely what's on offer and what's the price. And then, I mean, you have other functions, in this case, the place atomic and the buy atomic, that create transactions. And I mean, that depends on the use case, of course, but in this case, we have like two actions at the moment. One is to actually make an offer, and the other one is to fill an offer or buy an offer. So that's all quite typical, I think. And obviously, I mean, it looks ugly now, but I hope you can imagine that now I mean, this is everything Cardano related. From now, it's just like web development. So now, once you have this functionality, it's easy to turn that into a web application, especially if you have a server. So if you are willing to have a server, then the server can do this stuff, run these create this transaction and so on, and then from a website you can interact with and display it nicely. Okay. Are there any questions? Should we stop for today?
Okay. There was one, but you already answered it. So
Yeah.
Okay. What was that?
if the off-chain functions needed to have a backend or could be also used directly from the front end.
Right, I answered it, but I should say that you can also, I mean, obviously I wrote the off-chain functions now in Haskell. And right now there is no nice way to run Haskell in the browser, although the GHC is working on that, or actually IOG is also working on that. So I think I think in principle it's already possible. So right now The newest GHG versions have a way to compile Haskell to JavaScript. So in principle, it's possible already, I think, to run this in the browser. But I mean, I think nobody would do it at the moment. However, you also, I mean, if you are willing not to use Atlas, there are alternatives like Lucid, which uses TypeScript, which is also an off-chain framework. It's similar to Atlas in its functionality, so you can also query the blockchain and construct transactions, submit transactions, and so on. So that you could do serverless in principle. So for this application, you wouldn't really need a server, so everything could run in the browser. I mean, obviously you need some connection to a node, but I mean, I'm using Blockfrost or Maestro in this example anyway, and that's also possible from the browser. The second thing you would need, I mean, I am explicitly using this secret key file for Atlas, and I mean, to sign. But if you are in a browser, you typically would want to use a browser wallet like this Nami wallet. So you couldn't do it like that. So, but there are ways. So Lucid, for example, supports that you can connect to a wallet like Nami, and then I mean, Lucid would construct the transaction, but the signing, for signing, you would hand it to the wallet, and then a window would pop up, and I would need to enter my password and sign it like that without having access to the private key directly. So, I mean, this could all be done, and maybe we even should do that. I'm not sure. I mean, we could demonstrate how to do these things in Lucid instead of on the server side. But yes, it's possible to have serverless I mean, Cardano applications. I think most don't or aren't, because often for efficiency or other reasons, it's still good to have a server or database somewhere. But I mean, this could be done just in the browser. And then all you need is somehow you must give your Blockforce credentials or so. And then you can do all of that in the browser as well.
Okay, good.
Okay. No more questions?
No.
Okay.
Mm.
Then thank you very much. And luckily today it went better than last time. So now stuff worked. Okay. Okay. Then thank you very much. Have a nice weekend and talk to you on Monday.
Yes, thank you. Bye.
Thank you. Thanks. Bye.